Good morning all. This is Dr. D. Khalandar Basha, working as Associate Professor in Electronics and Communication Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to discuss programs related to 8051 under the course Microprocessors and Microcontrollers. So the slides are prepared by referring the textbook, the 8051 Microcontroller, authors Kenneth J. Ayala, publication Singh's Learning. So the first program we will see is develop 8051 program to move a block of data from external memory to another external data memory. So here we have external memory and this is 8051 microcontroller. So we want to move a block of data from some address block A1 to another address block A2. So for this purpose, we are writing a program where the data first will copy from external memory to 8051 internal memory. How many bytes we want to move, that entire thing will be copied from the external memory to the internal memory. Then from the internal memory, we are going to send the data to another address block. Now we will see the instructions step by step. So first we will move the number of data or number of memory location we want to copy from one location to another location into R7 register by using move R7 comma hash the number of memory locations. Next we will load the starting address which is present in the external memory into DPTR with the instruction move DPTR comma hash from address. We want to copy initially from external memory to internal memory. Then the internal memory address we are going to be load into R1 register. So with the instruction move R1 comma hash internal memory. Next we will fetch the data from the external memory through MOVX, where MOVX instruction is used for accessing the data from the external data memory. So MOVX A comma at the rate of DPTR. Now from accumulator we will load into internal memory where internal memory address is in R1 register. So for that move at the rate of R1 comma A. So from external memory we will copy the data into accumulator. From the accumulator again we will load into the internal memory. Next, for accessing the next data, the address will be incremented both in external memory which is pointed by DPTR and the internal memory R1 register will be incremented by 1. So this process has to be repeated until the number of blocks which we want to move. As we have kept the number of blocks or number of data which we want to move in R7 register. So for every data transaction, decrement R7. If R7 is not equal, that indicates still some more data we need to transfer. So go to loop 1. So this loop will be iterated until the number of memory locations specified are copied. Next, initially we have copied the external memory data into internal memory. The next step is from this internal memory, again we have to copy into the next external memory. So again we will start by loading the number of memory location to be copied into R7 by using move R7 comma hash number of memory location. Next, the address to which address we want to move, that will be loaded into DPTR by using the instruction move DPTR comma hash to address. Then the internal memory address will be loaded into one more register, that is R1, by using the instruction move R1 comma internal memory. Next, as the data we are copying from internal memory, we use the instruction move accumulator comma at the rate of R1. So now the internal memory data is copied into accumulator. Then we'll copy from accumulator contents to external memory by using the instruction move x at the rate of dptr comma a. So once one data is copied, for pointing to the next memory locations, increment dptr and increment r1. As for each data is transaction, the count we have to decrement, so we go for djnj. As the count is specified in R7, so decrement R7. If it is not equal, then jump to loop 2. So this loop 2 will be executed depending upon how many memory locations where data transferred. Once all the memory location data are copied, then we go for ending the program. Now we will see the entire program in single glance. Move R7 comma hash number of memory locations. Move dptr comma hash from address, which is nothing but the external memory address. Then move r1 comma hash internal memory. So the internal memory address is copied into r1. Next, data from the external memory to accumulator by using move x comma a comma at the rate of dptr. From accumulator to internal memory by using the instruction move at the rate of r1 comma a. For pointing to the next memory location, increment dptr, increment r1. So this loop has to be repeated until r7 is equal to 0. For that you write djnz r7 comma loop 1. This we have copied the external memory data into internal memory. Then we will copy from internal data to external memory. So for that, move r7 comma hash number of memory location. Move dptr comma to address. Move r1 comma internal memory address. Then we will copy move a comma at the rate of r1. Move x at the rate of dptr comma a. Increment dptr. Increment r1. djnz r7 comma loop. So this is the program for copying from external memory to internal memory, again internal memory to external memory. Next, use push instruction to put the number 82H in RAM location from 34H to 33H. Also write the same program without push instruction. So we know that the stack always will be pointed to the lower address. This is top of the stack. And we want to copy the data from 34 to 37. So this data, whichever we are going to be load, which is having the data as 82, 82, 82H like this. So first we will point the top of the stack to 33H, that is move sp comma hash 33H. Then the data will be copied, that is 82H, we will load into one of the memory location, that is 50H. So move 50H comma hash 82H. Then as we want to copy from 34, 35, 36, 37 location, that is 4 locations, that we will write into R7 by using the instruction move R7 comma hash 04H. Then push the contents of 50H locations into the top of the stack, that is 34 address. So push 50H. Then as one data is pushed onto the top of the stack, then we will decrement the count which is in R7. If it is non-zero, go to loop 1. So this loop 1 will be repeated until the data is copied from 34 location to 37 location. So let us consider the top of the stack is pointing to 33H. So move sp hash 33H. The data which we want to copy into that location is 82H. So we'll write move 50H comma 82H. Then how many memory locations we are going to access? 4 locations. So move R7 comma hash 04. Push 50H. So this 50H location data will be pushed onto the top of the stack. Then as one transaction is done, decrement R7 until R7 is equivalent to 0. So here we can use the register, from the register also we can copy. Next, the same program we are going to write without using push instruction. So first we will load the number of memory locations into R7 by using move R7 comma hash 04. Then load the starting address into R1 register. Move at the rate of R1 comma hash 82H. So the 82H data will be loaded into the memory location. So as one memory location is occupied, to pointing to the next memory location, increment R1 and count which is in R7 decrement. If it is non-zero, go to loop 1. So this loop will be iterated until the number of transactions has to be finished. Now we'll see the program at a glance. So move R7 comma hash 04, move R1 comma hash 34, that is starting address, move at the rate of R1 comma hash 82H, the data which you want to copy into that memory locations. For pointing to the next memory location, increment R1. So this has to be repeated until R7 is equal to 0. So for that, we'll write djnz R7 comma loop 1. Next, write a program to compute a sum of n numbers and save the sum at 70H. So we will take n blocks, that is n memory, n data, where we are going to add these two contexts. After the sum is generated for n numbers, we are going to move that one into a 70H location. So here we can have n number of data. After adding the sum, we are going to load that one into 70H location. So first we are going to clear the R0 register as well as accumulator by using the instruction move R0 comma hash 00 and clear accumulator. So move the data. Next one is for pointing to the next memory location. So we go for incrementing R0. So let us consider here we will take the number of data size is 15. So that we will write as n equivalent to 15. We will clear the R0 register and accumulator by using the instructions move R0 comma hash 00 and clear accumulator. So for the next data we are going to increment R1 because we want to add the first n numbers. So add accumulator comma R1. So first 1 will be added to accumulator. Then we will compare the R0 with hash n because n numbers we want to compute from 1 to n. So R0 is equivalent to hash n R0. If these two are not equal, go to loop 1. So this loop will be iterated for n number of times. So once all the first n numbers are added, then we are going to be load accumulator content into 70H. Next, generate a program in 8051 to count a number of 0 bits available in byte available in the external memory at 1000H. Store result a RAM bit count in the internal location 60H. So we are going to take a data which is of 8 bits. Here the objective is we need to find how many zeros are existing in this data. So for this, either you can shift the data towards right side or left side. Once the data is shifted, the data will be copied into carry flag. Then we will examine the carry flag. If carry flag is equivalent to 0, increment the count. Else, if carry flag is equivalent to 1, don't return the data. So for writing this program, the data can be shifted towards either left side or right side. Now we will see the instructions. Move R7 comma hash 08 because the data is 8 bits and we want to examine the 8 bits. So this count we are going to be loaded into R7 register. The external memory address we are going to be loaded into the DPTR by using the instruction move DPTR comma hash 1000H. Next, move XA comma at the rate of DPTR. So the external data we are going to be loaded into accumulator by using the instruction move X. Next, move R0 comma hash 60H. This is the address we are going to be loaded into R0 register. Next, initialize the memory address R0 with 00 because we have not checked any data. So first we are going to be load into that memory location, which is nothing but a 60th location. We are initialized to 0. The data, whenever we are shifted, if it is 1, then we are going to be increment this memory location contents. So now we will check whether the bit is a 0 or not by shifting or rotating towards the left side or right side by using RLC instruction. Rotate left with carry accumulator. Then we will check for carry flag. If carry is equivalent to 1, so no need to update the count. So we go for next iteration. If R0, that is carry flag, is equivalent to 0, then we have to increment the 60th location by using the instruction INC at the rate of R0. Next, as 8 bits we need to check, we will write DJNJ R7 comma loop 2. So for every iteration, the R7, that is count, will be decremented by 1. If it is non-zero, go to loop 2. So this loop will be iterated until all the bits are checked. Now we will see the program at a glance. So move R7 comma 08H, the number of bits we are specifying in R7. The external memory address we are going to be loaded into DPTR, like move DPTR comma hash 100. Then we will fetch the data from the external memory by using move XA comma at the rate of DPTR. So after counting, the result has to be stored in 60H. So we will load the R0 with the 60H location. Then we will initialize that memory location with a 0 by sending that 00 into that memory location by move at the rate of R0 comma hash 00H. Then we will rotate these contents either towards left side or right side. So for that we are using the instruction RLC accumulator. If carry is equivalent to 1, don't increment. If carry is equivalent to 0, increment the 60th location. So for that you will write JC. If carry is equivalent to 1, skip this incrementing. If carry is equivalent to 0, then increment at the rate of R0. Right. So for every bit checking, then we will decrement the count which is in R7. If R7 is non-zero, go to loop. So again, shift these contents towards left side by 1 bit. We will check whether it is 0 or not. Like this 8 times it will be repeated. Next we will see the next program. So write a program to exchange the lower nibble of data present in the external memory 6000H and 6001H. So in 6000 location and 6001 location, whatever the lower 4 bits are there, this we need to exchange. So you will write the program with R is an 000H, indicating the program will be stored at 000H address. External memory address we are going to be loaded into DPTR. So we will write move DPTR comma hash 6000H. That external data memory we are copying into accumulator by using the move X instruction. Move XA comma at the rate of DPTR. So now the external data which is at the address 6000H will be loaded into accumulator. Next, we will write move R0 comma hash 45. So in the internal memory at 45H we are going to be load this data by using the instruction move A comma at the rate of R0. Next, for pointing to the 6000H, 6001 location, increment the DPTR. So now the DPTR, as it is 16-bit, only lower 4 bits are sufficient to update. So either you can write increment at DPTR or increment only DPTR. So then we will copy the data from the external memory which is at the 6001 location into accumulator by using the instruction move A comma at the rate of DPTR. So now one data, that is a 6000 location data, now it is there in 45 location, whereas 6001 data is there in accumulator. Now the objective is we need to exchange the lower 4 bits. So for exchanging the lower 4 bits, we have the instruction is XCHD, exchange the lower nibble. We will write A comma at the rate of R0. So the R0 location, that is 6000H, the lower 4 bits will be exchanged with the accumulator lower 4 bits. Next, whatever the exchange data is there, that we are going to be sent to the external memory. So move X at the rate of DPTR comma A. So previously in 6000 location and 6001 location data is there. So now this data is copied into this lower 4 bits. Now here we need to get this lower 4 bits which is there in the internal memory, that is at DPTR. Next, for pointing to this memory location, we will write decrement DPTR. The data is there at 45 location, so that will be loaded into accumulator. So from accumulator to again we will be loaded into the 6000 H location by using the instruction move X at the rate of DPTR comma accumulator. So in this session we have discussed a few programs related to 8051 microcontroller. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.